Hello students, Stride here again. Today we get notes for 16.2.3. Chapter 16, Section 2, Part 3. In Part 1, we looked a little at just basics about Coulomb's law. Part 2, we did some calculations involving Coulomb's law and also with gravitational force. And then we compared electric force with gravitational force and found electric force was much bigger than gravitational force. Today we get a look at something we call the superposition principle. As we deal with this, we're going to again use Coulomb's law and not going to use the law of universal gravitation today, but that'll be coming back still. But we get the law of superposition. So, forces are vectors, so resultant forces, what we're going to be dealing with today, on a charge is the vector sum of all the individual charges. So far, with Coulomb's law, we've only worked with pairs of charges. What I'm working at here is just a little bit off of page 556 in your textbook. But we can have more. Coulomb's law also works when there's more than two charges, and that's what this whole prospect of using these resultant forces. So the resultant force on any single charge equals the vector sum on charge of all other individual objects that are present. So this is the principle of superposition from here to here. Principle of superposition. That's what we're going to apply on a few problems today. On page 559 in your textbook, we have this problem. Got a movie screen, and they give us some dimensions of the movie screen. They give us charges at some particles in the corners of those movie screens, and so listing this all out, now we would note that the Q's are in nanocoulombs. So nano means billionths, so we switch them to times 10 to the negative 9th, which is what they've done here, and here, and here. So nano times 10 to the negative 9th. And distances we're given as to in meters, so we've got to leave those alone, and then we have our KC here again. So that's all the data we're going to need to work with this problem. And here we have a little sketch. Got a movie screen. A little sketch here. Movie screen, distances, Q's labeled in the appropriate corners according to what they said here. Yeah, we might know. So we're trying to find the forces on Q1. So if we look at Q1 and Q3, Q1 positive, Q3 positive, that means they're going to repel each other. So it's going to go that way. And Q2 is negative, so it's attractive force to Q1, so it's going up this way. So we have forces going this way and this way, as illustrated here. Yeah, we want those two forces here and here. We want the resultant force up here. That's what we're going to end up needing to figure out. And easier than drawing it this way, if we take this and switch it up here to tail to head method. There's our resultant force. And this is the figure we're going to end up using, which they have drawn right here. Boom. Okay. So first thing we do, we go ahead and find the amounts of the two forces. So we have here, oops, so we've got force here, and we've got a force here. And calculations using Coulomb's law between points 1 and 2, which would be this vertical part of the component between 1 and 2, because 1 was down here, 2 was up here. So this one goes there. And then this one between 1 and 3 was the horizontal part of our thing, and it ends up in that one. So those are the two legs of a right triangle. That we can use, we have these, again, two legs of this right triangle. Boom. This one here, and this one here. And we can apply the Pythagorean theorem to find the resultant here. So applying the Pythagorean theorem, we take the 8.84, we take the 6.49. Now they put the 6.49 as negative because it is going backwards. In Pythagorean theorem, it's not going to make any difference because you square the negative, you square the positive, you get the same thing. So our resultant value is 1.10 times 10 to the negative 10th Newton. So we know the value of the force acting on point 1 now, or object 1. Then we want to figure its direction. So go back to our triangle again. Now we know the resultant. We know sides x and sides y. So they said the tangent, or they said it equals fy over fx. Maybe an easier way to remember tangent. Remember we said it's opposite over adjacent. And dealing with this is our theta. Opposite would be this y value, and adjacent would be this x value. And the x, again, is a negative. So we take those and divide them. And then take the inverse tan. And we find this theta to be negative 53.7 degrees. And as we go through these, make sure you run through the calculations, type them in, do the calculations, try as much as possible to understand the manipulations I'm doing. So what we're doing today, much more difficult. Should be able to definitely handle just two particles fine using Coulomb's law and finding it. Here, when we bring in 3 or 4 particles, gets a little tougher. Now we've got numbers 1 and 2 on page 560. So this. Of number 1, we have 3-point charges, Q1, Q2, Q3, illustrated here, Q1, Q2 being the same, Q3 different. Always good to list out what we have. And said Q1 and Q2 are 5 meters apart, and they form the base of our triangle. So Q1's down here, Q2's down here, Q3's up here. Now, we're going to need the distance between these, and we're trying to find the force on Q3. So we're trying to find the core force on Q3. It's good to start and just look at what the charges are, what direction the force is going to go. In this case, all charges are positive. That means all particles are repelling each other. We're concerned about Q3. So Q1 is putting an opposite force on Q3, and Q2 is putting an opposite force on Q3. Because like charges repel. They'll try to push it away. Now, we're going to need to use Coulomb's law to figure out how much these forces are. So Coulomb's law, we got the charges, we need the distance between Q1 and Q3, between Q2 and Q3. Now those distances are going to be the same. And if we sketch a little right triangle here, we would know that isosceles triangle, that this altitude is going to cut the base in half. And it said our height was 3.5. From Q1 to Q2, it was 5. That means this one's got to be 2.5. And it's got a little right triangle here, we can use Pythagorean theorem. And we find that this side is 4.3 meters. Same thing over here. So the distances are the same, the charges are the same. That means our two forces are going to be the same. Writers of our textbook calculated both of them out. They are identical. You only need to calculate one of them out. The only difference is one is going up and to the right and one is going up and to the left. But the values are the same. So using Kc times Q1 times Q2 divided by the distance between them squared. So now we know that we have this force here, and we want to try to find the resultant. And the resultant is going to come right up the middle. So if we're going to try to find that resultant, we want to break both of these two forces down into their components. So one would go here and here, and the other one would go here and here. Or we can set them here and here and here. So now we would note that this x part here is identical to the x part here. So they're going to end up canceling each other out. So we're only going to end up with the y parts. If we're going to be breaking this down as components, we're going to need to know the angle. So right here, switch colors here. Let's go to orange now. So right here, we find an angle, and that angle is going to correspond to this theta right here. Remember from old stuff, tangent equals opposite over adjacent. So opposite was the 3.5, adjacent is the 2.5, and that gives us that angle there. That is the same angle that we have up here in the area we're more concerned about with. So this is our theta right here. So then we want to find this value. So we're looking at opposite. We know the hypotenuse. So sine equals opposite over hypotenuse, or opposite equals sine times hypotenuse. And so here we find that value. Now, on the other one, it's going to be identical, and they demonstrate that here. Then the x's, as I mentioned a little bit ago, this part and this part are going to end up canceling each other out, and they demonstrate that here and here they show you that the values are. We really don't need to calculate them. One of them's in a negative direction, so they end up canceling out, and we get 0 newtons in the x direction. So the part we're concerned about with is we have this part going up, at this part going up. So there's 2 of them going up, so this is going to be twice as high as either of those. And we just add them together, and we get 2.24 times 10 to the 10th. So our resultant is 2.24 times 10 to the 10th newtons pointed upward along the y-axis. So, bring back in a little trig stuff here. Things work out pretty nice. Yeah, number 2, we got 3 parts, all dealing with the same charges, same points. So, we got them placed at the corner of a square. They told us the square was 15 meters on each, centimeters on each side. We don't want 15 centimeters, we're going to want 0.15 meters. And for part A, we want to know the charge on the 3.0, so we want to charge on that Q1. And with the way the authors of textbooks just said Q1 equals Q2 equals, and they said Q1 had to be up here. Q2, -6, was in the upper right, so this one's Q2. Q3 ends up being down here, and Q4 over here. Now we're concentrating on particle 1 right now. So we want to know what's happening here. The preceding problem, think about positives or negatives. Now Q1 is a positive, Q2 is a negative, Q3 and 4 are both negatives. So Q1 is being attracted to Q2, to Q3, and to Q4. So I'm going to apply Coulomb's law. I did here 3 times to find each of those forces. But before we do that, we have to know the distance between 1 and 4. We've got to know this distance right here. And we can use Pythagorean theorem again. We've got a little triangle. You know, this was 0.15. This is 0.15. They left them in terms of 15, and we got 21 centimeters. So we're going to get 0.21 when we calculate it. So again, so keep talking about, make sure you're doing the calculations. Follow along. Write down stuff that's going to help you understand it. Then, using the 0.21 0.15. 0.15 is distances, the charges values that were given. We find the force between points 1 and 2, between points 1 and 3, and points 1 and 4, and we get these three values. So bringing out, we now know these are three vectors we're trying to combine together. One going in the y direction, one going in the x direction, and one going at an angle. We know this one's 5.5 newtons. 1 and 2 is 7.2 newtons, and then we had between 1 and 3, 2.9 newtons. Now, the one at the angle here, the 5.5 newtons, we're going to want to break into its components. And we would know that an angle, this thing is coming down here, it's got to be at a 45-degree angle. So that's our theta, because we got a square, divides it in half. So we find the x component of that. We would look at this little triangle right here, and the x component of it deals with the opposite side, or the adjacent side and the hypotenuse. So we can, and here it would actually not make any difference either, but we end up taking a 5.5 times cosine of 45, and then we go ahead and add that to the 7.2. So 5.5 times cosine of 45 gives us the x component of our diagonal 5.5 force. Add that to the horizontal force of 7.2. You end up with 11.1. We apply a similar thing for the y component. We already know we got 2.9. That it's going in the downward direction, so they identified it as negative. And then we take our angle, and using negative, use 5.5 times sine of 45, we get component coming down this way. So we got negative 2.9, negative 3.9, we get negative 6.8. So now we got our total x and our total y. Using Pythagorean theorem, we can find this resultant coming down this way. So, Pythagorean theorem right here. Calculations you're going to want to do. So 11.1 squared plus 6.8 squared. And we find 13.0 squared. Then we want the angle. So tangent 6.8, inverse tan 6.8 over 11.1. We're finding this angle right here at 31. Oops, actually this angle here at 31. Part B, we apply same idea. This time though we're trying to find on the 6.0 charge. Relabel this again. This is our Q1, our Q2, our Q3, our Q4. This time we're trying to find the force on the negative 6.0 on the Q2. So this time we want the force here. Again, Q1 is positive. The other ones were all negative. So Q1 and Q2 are going to be attractive force. So it's going to go this way. This way. Q4 and Q2 are both negative, so they're going to repel. So it's going to try to go up this way. And Q3 and Q4 are both negative, so it's going to try to go this way. So those three vectors are the ones we're going to try to figure out. Yeah. So bring those down here. So we want this one, and this one. Now, the force between 2 and 1 we calculated on part A. It's the same force, and that was 7.2. So this one's 7.2. The force between 2 and 4 is 22 newtons on upward. No, excuse me, I wrote down the wrong one. Let's back that out. Force between 2 and 4, 2 and 4 is 22 newtons. I did write the right one down. And the force between 2 and 3 is 2.9 newtons. And the distance between 2 and 3, again, for your calculations from the last part, is still 0.21 meters. So those are forces. Again, we would know this is a 45-degree angle. Or this is a 45-degree angle, and the sine and cosine of 45 doesn't make any difference. So, if we want to find the x components, we've got negative 7.2. Let's switch colors here. Negative 7.2, that's this part. We got this book here. This one ends up being 2.9 times the cosine of 45, and that's going to be a positive value. So we end up with negative 7.2 plus 2.1. This should be 2.1, giving us negative 5.1. So our force in the x direction is 5.1 negative newtons. Then we want to worry about our force in the y direction. So in the y direction, we got 22 newtons going up. 22 newtons going up. We need then this part over here, which we can calculate by 2.2 sine of 45, which still is the 2.1 we had before. So this one's 2.1. So we take 22 plus 2.1 and we get 24 newtons. So the force in the y direction is 24 newtons. Now that we know the x direction and the y direction, we can use Pythagorean theorem. And the Pythagorean theorem, we can then calculate the resultant value. So here's where the main part of what we need there. Using the Pythagorean theorem, calculate, we get 25 newtons. And then we want our angle. So now we got fx going off this way. We got fy going this way. So if we sketch out a rectangle here, draw this up here, we can try to find this theta right here. And they use tangent is opposite 24 over adjacent 5.1. So using that, we find this to be 78 degrees. So our answer is 25 newtons, 78 degrees above the x-axis. And part C. Yeah. Went through and just got the same stuff we had before, what we have from the book. And like before, we had Q1 here, Q2 here, Q3 here, Q4 here. This time we're wanting on the 9.0 charge, which is our Q4, so we're trying to find what's happening to 4. And like we did on the first two problems, Q1 was positive, the other three were negative. So that means Q1 and Q4 are repelling, or Q2 and Q4 are repelling. So they're going down this way. Q1 and Q4 are attractive, so it's coming up this way. And Q3 and Q4 are repulsive, it's going that way. So those are the three vectors we want to apply. Now, well, from part A, we did between 4 and 1, so we know, resketching the little sketch I just made, we get this, this, and this. So this one is 5.5 newtons. The one going down is between 2 and 4, which we did on part B, is 22 newtons. And going across, we have to calculate between 3 and 4, so we're trying to calculate between 3 and 4 here. And using Coulomb's law, we get 8.6 newtons. And so we got, in the x direction, we know we got 8.6 newtons. In the y direction, we got 22 newtons negative. But then we have to break down the 5.5 newton into its components. So we look here and here. Again, we got a 45-degree angle. So they're both going to be the same value. and we'll take 5.5 times the cosine of 45, or the sine of 45. Either one's going to give you the answer, which is what we did here and here. Now, for the x part, and 5.5 times cosine of 45 ends up being 3.9. For the x part, it's going in the opposite direction, so we're going to minus 3.9 newtons. And for the y part, it's going in upward fashion. So it's going upward, so we want to add 3.9 newtons, which is what our authors did here and here. So we end up with 4.7 newtons and negative 18 newtons. And then using those two values, using these two values, apply the Pythagorean theorem, and we get our resultant of 18 newtons. Then we want our angle. So we had 4.7 newtons in the x direction. We had 18 newtons in our y direction going down. So we want something here. And if we find this theta, it's going to be the tangent of, it's illustrated right here, the tangent of 18 opposite 18 over adjacent 4.7, and applying the inverse tan to that, we get 75 degrees, and that's what we have. So that's a little work with the superposition principle. Yeah, I would expect you to be able to handle 2 points right now. If you're a little uncertain on dealing with 3, 4 points, it's probably okay for now. We'll look at some more of these as we continue on.